just got short. We have our unit. When we read decimals, we read them along the bottom and we read them along the left. This is where we read answers to a decimal problem. But we calculate multiplication of decimals up here.
I've never said it that way.
So let's say, and I'm gonna get a small decimal, I'm gonna get a small whiteboard. They're in my blue bucket. Yep, or over there. Sorry, I didn't think of that. So I'm gonna multiply a decimal today. I'm gonna multiply 2 and 3/10 times 5 and 2/10. Now we have to figure out where we're going to put these numbers, because this isn't like the regular checkerboard. This is the decimal checkerboard, and the only thing we know for sure that can get us to the right place is that a unit times a unit makes units. So we have 5 units and 2/10 and 2 units and 3/10. So let's just make sure that our answer to 5 times 2 lands on one of these green unit squares. So if I put it here, 5 times 2 lands on a unit, because 5 units times 2 units makes 10 units. But I have these other tenths. I have 2/10 and I have 3/10. Oops. So I'm gonna have to use a different green square. If I move my number over like this, 5 times 2 makes units. 5 units times 2 units makes units. This will work because now I have space for my 2 units. 5 and 2/10 times 2 and 3/10. This is my problem. I have to move it over because I have my 2/10 here. I have 5 units and 2/10, and I'm going to multiply it by 2 units and 3/10. Now, between the teachers here, these numbers are not lined up with anything. Don't worry about where they are. What matters to us and anybody who wants to use this board is that our units and our units, when they meet, when my fingers meet, they have to be on green. So I'm not going to do this whole problem yet. Let's set up a couple more problems, okay? Let's say we want to multiply 0 and 52 hundredths times 2 and 3/10. I need a 0, okay? I'm going to need always to have a unit in order to find where to put the problem on the unit. So I'm going to start again with 2 and 5/10. No, I changed, 2 and 3/10. Let's multiply by 52 hundredths. So I have 0 units and 5/10 and 2 hundredths. So this is my unit and this is my unit. If I meet them together, am I on a unit square? No. So let's find out what happens if I move this down. This is my unit and this is my unit, and if I meet them together, are they on a green unit square?
Yes.
Yes. So if I multiply this problem, my answers are going to be in the right squares. Let's try change it up again.
How come we aren't down here on the X and Y axis?
You know when you slide on the regular checkerboard, you slide everything?
You're going to do
when
that.
we're
gonna
done,
do
we
that.
slide our answers and you
Okay.
only read your answers here.
Great.
That's when that happens.
Okay.
So if I want to do 23 hundredths times 52 hundredths, I need a 0 because I always need a unit to find my place on this board. So if this is my unit and this is my unit and I multiply them together, I should be on a green unit square. Am I on a green unit square? Nope, no, I'm not. So let's see what happens if I move it down. This is my unit and this is my unit, and if I multiply them together, am I on a green unit square?
Yes.
Yes. So this is the place to start this problem.
Weird.
It is a little weird. So as these numbers get further and further away, or if I do this, essentially, if the numbers start getting really, really big, or I should say really, really small, and far away from this decimal point, let's say I need these numbers now, 4315. Just to play, like, what if a kid's like, let's do a big number, and you're like, Dakota didn't tell me how to do that. I wouldn't be helping you. So we have 4315, 4,315 ten thousandths, and
232 10,000.
Now, you notice I'm just taking the same color out because there's no way to use these colors to indicate really what the answer is going to be, unlike in the regular whole numbers one. So I just use the one that's easiest to see because I find this maddening. I can't even, it's a poorly designed, that one's just poorly designed. 3, 2. And if a kid asks you, like, why are you picking those? You can just explain it. Because they're easy to see, and because, as you're about to see, these colors that I'm using here don't help me find the answer. What helps me to find the answer is the squares. All right, so now we want to see if we're going to get our answer to land on the correct square. So my unit is a 0, and this unit is a 0, and I don't have a 0, so I need a 0. All right, so this 0 times this 0, can anybody show me where it needs to land? There. So does anyone see that we might have reached the limit of this material?
Yes.
And that happens on the regular checkerboard, right? If you want to get into the 10 millions, it's not there. So if I wanted to multiply this unit times this unit, this number would be in the right place. This number, I can certainly extend this because look how the pattern goes. It's never going to change.
They could figure it out.
We could do that problem, but when we slide, it just means that the answer is going to be out here. It's going to actually be like this. Like 10 millionths, 100 millions. Our answer might be in the 100. But if you just want to say, like, you know what, kid, let's not trouble ourselves.
Oh, sometimes I love it. I'm like, yeah, just build it.
Yeah.
Build it.
And or you could get out those little movable squares,
Oh yeah,
right?
you can add
We
the
could just
movable
keep going, and
squares
that'd
to
be
it.
fine. So the ultimate beginning of this work is, where do I put the numbers?
And that has no math purpose. That's just teaching the material.
Yeah, we're not talking about math
I
right
know.
now.
That's what I mean.
But
So-
still, they're working on like the units times.
You
units,
do need to
what
at
they
least
mean.
know,
Yeah.
yeah.
Still.
And if you wanted to extend that, so let's say you've set up your problem, and units times units is gonna land on units. Well, tenths times units is what?
Tenths,
And hundredths times units is?
hundreds,
And thousands times units?
thousands.
And 10,000s times units is thousands. And we gotta make sure these are landing in the right place, right? Because this is helping me to remember, oh, these are 10,000ths, all of these are 10,000ths, and all of these are 100,000ths. Okay, so let me stop and ask for questions from you guys.
That was my question.
Do you set up this when you explain like having tens, like I don't know, 25.3?
Yeah. Here, let's say we do have 25 and 4,315 10,000ths. We still only really care that our units times units makes units. That's how we find our place to start.
Oh.
From there, even if we have, 925, where does the 5 go? That's where we kind of ubicarnos, like I want to say. Like, that's where you find yourself. And I did teach this last year, and it only took them it was harder, I think, for us than it was for them. They were like, oh, you find the unit. Okay, boop. They, like, set it up, and I was like, oh, phew.
I don't know. We'll make them way harder.
Okay, I have 2 questions.
Yes, please.
I won't be teaching it, so I'm gonna. But I just want to. So what happens when you're solving it and you have to regroup?
Oh, okay. Well, luckily they know how to do that from the other material, which is from lower L, the
So,
regular one. So the same thing happens. So let's not make it this hard. Let's just do a problem that we can do right now. Is that okay?
Yeah, like a
smaller problem.
9.9 times 9.9. I'm just curious, like, what is that? How does that
All
play
right, so
out?
we'll definitely need regrouping here. All right, so what problem do you think we just made? Can you tell me?
9 and 2 tenths.
5,200.
Times 5,200.
Right, because these have to be our units, right? Okay, so okay, I'm not gonna say anything else about that. So we got this, and this, and this. Now, it's totally fine to have a like larger, I know it's smaller, but like 3 digits in your multiplier, even though we don't like that, you know, like we want it to be like a bigger number on top, but because this is our multiplier, whatever number is on the bottom, you need to have on the right. And whatever number is on the top, you need to have on the top. So if you did want me to do this
You need to switch the
times
directions.
this, then we'd have to switch those numbers. So I'm just gonna do what we have. It doesn't really matter right now because we're not doing it on paper. We're doing it on the board and the answer will come out the same. Okay, so you know how you multiply, like regular, we all know this, but the kids might not. You always start with your 2 smallest digits, right? So I tend to forget that and I'll be like, oh, let's start right here. Like, why not? No, you gotta start here.
Mm-hmm.
So what is 2 hundredths times 2 tenths? And if you're like, I don't know, you can always dumb it down and say, well, what is 2 times 2?
4.
4. All right. And what is 2 times 9?
18.
All right. So assuming kids know how to use this work, they'll go like this. Okay. I mean, obviously that happens sometimes, but that's another lesson. Okay.
They
We're
know to
done
carry.
multiplying by 2 hundredths. Let's multiply by 5 tenths. What's 5 tenths times 2 tenths?
10.
All right. How's that?
No.
What's wrong with that?
Zero,
Zero.
unit.
Okay, so 1 10 and 0 units. All right, what about 5 tenths times 9 units?
45 plus, oh, wait, we don't need to add that.
All right, 45. Am I good? All right, we're done multiplying by our tenths. And what's 0 times 2?
0.
And what's 0 times 9?
0.
Okay. We did regroup in the sense. Is that
Yeah,
what you
no,
were
that
wondering
works,
what would
yeah.
happen? Okay, so now that we're done, we're going to slide light green, light green, light green, light green. Or you could say hundreds, 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 hundredths. All my tenths, my tenths, my tenths, my tenths. And then my units. I don't need to add, but now I do. And what's 2 plus 5?
4, 6.
7.
Oh, that was a 5, not a 4.
Okay. And how do I read my number? I always read it on the bottom. And I can say that I have 4 and
784,000.
94,000.
94,000.
80.
94.
The kids know it better than us because they've been working with the colors their whole lives.
We're still getting used to those colors.
What questions right now?
No, it's just the setup. The thing that is tricky with this one.
It is.
What is different is the setup.
Yeah.
I have a question. And I have
Do you
this,
want-
I struggle with this on checkerboard. Yeah, I guess we can be done.
I have a checkerboard.